Okay, in this video I'd like to show you an example calculation of signal to quantization noise ratio of a DS0, that is sort of standard digital voice. And if you'll recall, a DS0, which is really very important to this course, has a sampling rate of 8 kilohertz and a sampling depth of 8 bits. And in the lecture I showed you the equation that gives us the signal to quantization noise ratio. It's SQR in decibels is 1.76 decibels plus 6.02 times n, where n is the bit depth, and now we should probably write that 8 bits is equal to n here. Sometimes we use a capital D for bit depth, sometimes little n, plus 20 log base 10 of the ratio A over A max. Okay, and this equation was given, and I hope I convinced you that the signal to quantization noise ratio is a function of both the bit depth and the signal amplitude relative to the maximum possible amplitude. Okay, basically the larger the bit depth, that is the larger n, the smaller the quantization steps are, and the smaller the quantization noise is, and therefore the larger the signal to quantization noise ratio. Also, as A approaches A max, that means my signal has the maximum strength, and that a stronger signal also increases the signal to quantization noise ratio. Okay, so part A of the problem, calculate the SQR in decibels for a signal amplitudes that are 10%, 50%, and 90% of the maximum amplitude. So basically we're just going to plug into this equation. I'm going to say that the SQR in decibel units is equal to, well, there's 3 cases here, so I'll just do 3 equations. And I'll go 1.76 plus 6.02 times 8 plus 20 log base 10. Let's see, A divided by A max is 10% for the first case, which is a 0.1. Hey, that one's easy. The log base 10 of 0.1 is negative 1. Negative 1 times 20 is minus 20. So I can go 1.76 plus 6.02 times 8 minus 20. Let's see, 6.02 times 8 is 48 plus 0.16. And so for this one we get, let's see, 1.76 plus 48.16. 1.76 plus 48.16 is 49.92 minus 20, which is 29.92 decibels. Okay. The other problems have got the same numbers except a 0.5 for the amplitude ratio and a 0.9 for the amplitude ratio. So this one's going to be excuse me, the same 49.92 decibels plus 20 log base 10 of 0.5. And this one, if you multiply it out, you're going to get 43.9 decibels. Finally, the third one is calculated the same way with the 0.9 for the amplitude ratio. And if you multiply this one out, you get 49.0 decibels. Okay? In other words, I've given you 3 different values of the ratio A over A max, and I've given you a fixed n and asked you to calculate 3 values of the SQR. For part B, I say let's let the SQR be given as 45 decibels, and calculate the signal amplitude A over A max. Basically, I'm going to go up here. This is like one of your homework problems, and I'm going to solve this equation for A over A max. And I know that SQR, so let's see, to get this by itself, the first thing I'm going to do is get the 1.76 and the 6.02 times n over to the left-hand side. We still have the case of 1.76 plus 6.02 times 8, so it's 49.92. So I'm going to get the SQR on the left-hand side, and I'm going to subtract 1.76, and I'm going to subtract 6.02 times 8. And that's going to leave me with 20 log 10 of the ratio on the right-hand side. But I'm going to go ahead and divide by 20 right away. And that's going to leave me with log base 10 of the amplitude ratio on the right-hand side. So you can see from this equation down to this equation. Finally, I can raise 10 to the power of both sides. 10 raised to the log 10 is the thing inside. So it's going to give me the solution I want, A over A max. And A over A max then is 10 raised to the SQR minus 1.76. You know what I'm going to go ahead and do is calculate that part. My SQR is given as 45 minus, and I already know that 1.76 plus 6.02 times 8 is 49.92. All over 20. And if I multiply that out, let's see, I get a negative 4.92 in the numerator. I'll go ahead and do it. 45 minus 49.92 is equal to that, divided by 20 is equal to that. So this is negative 0.246. Okay? And so this is going to be 10 raised to the negative 0.246. Again, I'm going to raise 10 to both sides of this equation. It leaves A over A max by itself, and it leaves 10 to the minus 0.246 on the right-hand side. And so if I do 10 to, shift 10 to the x, negative 0.246, I get 0.567. 0.567. And that could also be written as 56.7%. And that makes sense because when I had an amplitude of 0.5 or 50%, I got 43.9 dB. When I had an amplitude of 90%, I got 49 dB. So the 45 dB is in between the 43.9 and the 49. Therefore, I expect my A over A max value to be somewhere in between 50 and 90%, and indeed 56.7. Oops, sorry, it went off the bottom there a bit. And indeed 56.7 is. Okay, so I hope that example helps you with your homework. Thanks for listening.